All right, back again to talk about steel. In our previous video on Martensitic stainless steels, part 1, we talked about types that have a maximum carbon content of 0.15% and hardness in the low 40s and below. If you did not see that video, please do so now. Go check it out. If you did, thank you very much. But for a quick recap in case you missed it, here's a rundown. What did we find out? Higher carbon content allows us to achieve higher hardness and strength with heat treating. And higher chromium and other elements can improve corrosion performance and or mechanical properties. So there you go. In this discussion, we cover the types where hardness would be from the mid-40s to 60s on the Rockwell C scale before tempering. First are several grades that are small modifications of the chemistry we saw in type 410, which was discussed in the previous video. They have similar applications but are utilized where 410 is not quite as satisfactory. Type 414 at 0.15 max carbon and 11.5 to 13% chromium has nickel added at 1.25 to 2.5%, which improves its ability to harden and adds toughness that makes it more useful in the low 40s RC hardness range than type 410, which again was previously discussed. The nickel also improves corrosion performance in some environments. In addition, it improves mechanical properties at modestly higher temperatures as compared to type 410. Type 431 at 0.20 max carbon, 15 to 17% chromium, and 1.25 to 2.5% nickel has improved corrosion performance from the higher chromium as compared to either 410 and 414. Type 418, Greek Ascoloy, at 0.15 to 0.20% carbon, 12 to 14% chromium, 1.8 to 2.2% nickel, and 2.5 to 3.5% tungsten for higher strength at elevated temperature above those where 403 and 410 are used. Aerospace applications in jet engines or land-based gas turbines would be examples. Type 422 at 0.20 to 0.25% carbon, 11 to 13% chromium, 0.5 to 1% nickel, 0.75 to 1.25% molybdenum, 0.15 to 0.30% vanadium, and 0.75 to 1.25% tungsten. Whew, say that 10 times fast. So, after all that, 422 is used for the complex requirements at elevated temperatures. Next up is a type that can easily be considered as its own group of alloys. Type 420 is very broadly defined as 0.15% minimum carbon with 12 to 14% chromium. Now, this is the first time we have come across a grade with only a minimum carbon specified in these videos. We know how important the carbon content is in Martensitic stainless steels, so we can expect a wide variation in hardness and strength depending on the carbon content. Hardness can range from the low 30s to the mid-50s on the RC scale. In the most common compositions, the carbon is in the range of 0.3 to 0.4%. Common applications are in cutlery and plastic molds. There are also free machining grades indicated by the F suffix, 420F. Always be looking for further specifications that define the material to assure the final product will do what it needs to do in service. Just make sure to check the specs. That's it. Lastly, we have a group of alloys in the highest range of carbon in the Martensitic series, the 440s. Chromium content is 16 to 18% and has 3 variations with differing carbon content. The higher chromium content improves the corrosion performance over type 410 and 420, and the higher carbon increases the strength and hardness. 440A has 0.60 to 0.75% carbon, 440B has 0.75 to 0.95% carbon, and 440C has 0.95 to 1.25% carbon. Hardness from the low 50s for A and mid for B, and they are commonly used in cutlery. 440C is typically used at around 60 RC and is utilized in valves or bearings and other applications where both corrosion and wear resistance are important. As usual, we caution viewers that chemical composition can be further restricted by specifications and add important additional requirements. Check the specs. Parts that need prolonged resistance to fatigue will often specify a premium version that has been melted and refined a second time under a vacuum to remove any residual impurities that may remain in a single melted alloy. More on that in future videos. We appreciate you tuning in. Please don't forget to like the video if you haven't, and subscribe. Please click here. If you missed the previous videos and want to catch up, click here. Thank you guys for tuning in, and this is Michael with Michelin Metals.